Okay, let's start then. So Ismail, do you have a prior experience on the firewall?
Yes, I do have on Cisco SA.
On Cisco SA, okay. And any
A little
expectation
bit
from
on checkpoint.
for Palo Alto? Any expectation?
No, I don't have any experience on Palo Alto.
Okay.
So that's why I want to check what is the actually is a 4th generation firewall.
Okay. All right. So let's discuss about this Palo Alto. So let me just start sharing the screen. I hope you are able to see. Right.
Yes, I can see that.
Okay. So let's talk about Palo Alto Firewall. So Palo Alto Firewall is a next generation firewall. This is market leader nowadays, and this firewall you can manage individually like Cisco SA, and you can manage it from central location like a checkpoint. So okay. So both option is possible for you. You can manage if you don't have any central device to manage this. So no problem. You can manage it individually. And if you want to manage it from central location, so you can manage through Panorama. Right. This is having SP3 architecture. So this SP3 architecture is making this Palo Alto firewall unique, which is making this firewall to process the packet in a fastest way. Also, the Palo Alto firewall is having dedicated CPU and management, dedicated CPU for management plane and data plane. That means, let's say, you know, data plane and management plane, right? So we have in firewall 2 plane. One is the management plane.
Yes, I do know.
You don't know? Or you
I
don't
know
know?
about the data
Okay.
plane and management plane.
All right. So we have management plane and data plane, right? So you can manage this one. So if you just want to manage the firewall, so you would be connecting to management plane, and if any packet is coming to the firewall and being processed, this is processing using data plane. So for management plane and data plane, it has a dedicated CPU. It's not the combined CPU. In earlier firewall, you might have seen that earlier firewall was using same CPU for management plane and same CPU for data plane. Here it is different. For management plane, there would be dedicated CPU. And for data plane, there would be dedicated CPU. What is the benefit if you have a dedicated CPU? In any case, whether management plane or data plane utilization go high, okay, they are not going to affect each other, right? For example, you might have seen in your organization, let's say if there is attack is happening on the firewall, and firewall is trying to mitigate those attacks, and due to any reason your CPU utilization gone very high, so you won't be able to access the firewall. So if you talk about ASA or a checkpoint firewall, which is having a shared CPU model for both one. So if the firewall utilization go high, you won't be able to access firewall device itself. Here the story is different. Even though your data plane utilization go very high, you would be able to access your firewall, or you would be able to place the rule. And you can use this firewall to protect your on-premises network, and also you can protect your cloud network. That means you can deploy this firewall on the cloud as well. Also, Palo Alto firewall having the capacity to send the logs to the central location. So if you have multiple firewall in different location, India, US, or UK, these are the three location, and you have a separate gateway to protect them. So all these firewall logs can send to central location, maybe the panorama which you have placed on US. So it can send the logs to Panorama device. All the gateway can send the logs to Panorama device. Right. Now, if I talk about next slide, so next slide we have discussed about single pass parallel processing architecture. So this is the single pass parallel processing. In other firewall, you might have seen the packet which is coming on the firewall that is being processed one by different engine. Here, if the packet is hitting the firewall is going to process the traffic parallelly, okay, and it is going to process the traffic in a single pass. So for example, if the packet hits, and on the packet, if you have enabled multiple checks, so for example, let's say packet is coming to the firewall, and firewall on the packet you have enabled multiple checks. You have enabled application ID check, user ID check, and content ID check. So all these checks would happen in a single go. Okay, that's what this Palo Alto firewall is capable. And to support this, we have parallel processing hardware. So on data plane, we have networking, security, and content filtering hardware. Okay, so all kind of networking function would be performed by networking hardware. Security function, for example, app ID, user ID, this kind of security function would be performed by this security hardware, and content filtering function would be performed by the content hardware. Okay, and for control plane, we have management, and through management, we can control all these functions, right? So this is the architecture of the Palo Alto firewall, which is really unique, really makes this firewall unique among whatever the firewall available we so far. Right. If we talk about packet processing, so packet processing happen in a 5 steps majorly in Palo Alto firewall. When the packet come to the Palo Alto firewall, it does perform initial packet processing where it looks source zone, policy-based forwarding, destination zone, and NAT. Okay. After that, the packet would go to next step where security policy would be checked. Okay. In security policy, it is checking the traffic is allowed or not. Once it is allowed, session is going to be created. And then it go for the application checking where if the traffic is encrypted, so this is doing the applying the decryption policy. Okay. And if it won't be able to identify the application, I mean, if there is a custom application is created for any particular type of port or protocol, so it is going to check application override policy. If not created application override policy, then it is going to check application ID. So are you aware about this feature, app ID feature?
Yes, I heard about this, but I don't know how it works.
Yeah, I mean, working, I would, cover in course actually how it works, because for app ID there is a separate lecture itself. But what happened basically, app ID is basically a function where firewall would be able to identify layer 7 traffic. So I would say that, let's say this is system which is generating the traffic for the internet, and the traffic is generating for the Facebook, right? So for Facebook, on the firewall for Facebook, we have app ID. So basically on app ID, it is mentioned that all the parameter for the Facebook is mentioned, and on app ID you can provide granular control. When I say granular control, that means you can decide over here that what kind of traffic for Facebook should be passed through the firewall. So for Facebook you can apply all the function that user should be able to access Facebook in a full-fledged manner, or you can decide that user would not be able to post but just be able to access this. User would not be able to chat, just be able to access its a page, or user would not be able to make video or voice call. All those things you can decide. Okay, a granular control you can define. So you can define that whether Facebook would access on read only mode or also write mode. When I say write mode, that means user would be able to perform all these function. Okay, but in read only mode, it would be just able to open its page. So basically how app ID is working, in app ID, basically signature is defined. Signature means method is defined actually in app ID. So we have different types of method. We have get method using which user can access the page. We have post method using which user something can post on the page, right? So there are different types of method. So in the signature, it's a define different method. So when you enable the app ID, an app ID, you just enabling read only access. That means only get function is allowed for that particular application or for that particular domain. Okay, so in nutshell, we can say that by using layer 7 function or HTTP method, this is granular control is being allowed for a particular application. So using application ID, your firewall would be able to detect the application, and whatever the control you have applied for particular application, those control would be effective for the user traffic. So post checking the application, this is checking the security policy. Okay, and in security policy, it is going to check what are the profile allowed. So basically here what we do, we do the content inspection. On this step, basically content inspection happen. So here firewall is checking whether the content is okay or content is malicious. Those things is being checked over here. So we apply different types of security policy. For example, we allow vulnerability protection, which is nothing but IPS profile. We apply AV checking over here, antivirus, which apply the file checking, file policy we apply. So all those things is going to be checked over here as per profile, whatever your profile applied on the particular rule. So based on the profile, it is going to check what should be allowed and what should not be allowed. If firewall find anything malicious, for example, it's trying to download any malicious software. So on that case, security profile is going to check it, whether this traffic is malicious or not. And based on this is going to allow a drop. And after that, post policy processing happen. In post policy processing happen, if it has decrypted the traffic, now it need to re-encrypt because now it would be sent over the network. And finally, NAT need to be applied and packet need to forward to the destination. So overall, there are 5 steps on which entire packet is being flowed. Right. So I'm directly coming to demo over here. Let me just show you something. This is my Palo Alto firewall. In this Palo Alto firewall, we have dedicated interfaces for management. So this is management interface. For this one, I'm just going to assign this IP. And then we have another interface. For this one, I would assign this IP 192.168.2.1. And then we have this interface. This is connected to internet side. So this is, I would define that this is untrust. Okay. And for that, I'm going to assign dynamic IP using DSCP. When my workstation, this workstation, in one of the interface, I'm just going to assign this IP 192.168.2.10/24, and gateway would be my firewall IP, this IP. Another interface I'm going to use for the management purpose. So here I'm going to assign this IP 10.0.0.10/24. So from same workstation, I can access the firewall management IP, and from same management workstation, I can access the firewall internal IP. So when I would try to hit internal IP, it would be going on this interface via switch. Okay. And if I try to browse internet on this workstation, so it is going on the firewall, and through firewall, it is going to reach over the internet. Right. So on the firewall, we also configure NAT, and netting I would do for this internal subnet 2.0/24, it should be netted to the outgoing interface IP, which is Ethernet 1/4 interface IP. Right. So let me just show you demo. I would try to make internet communication through the firewall for this workstation. So let me just show you. So I'm firewall. Let's assign management IP first. Default username is admin, username password. We can change it. Admin is the old password. New password I'm going to assign test @123. Test @123. If you want to configure a firewall, so we can go to configure mode like in Cisco, and here we can set device config system, because we just want to manage system IP. That's why we just given the device config system, and I just want to configure IP address, so we can define IP as address, and then I can define 10.0.0.1 and net mask 255.255.255.0. Since we are defining it static way, so I can set run the command set device config system, and this is a static IP address. So I can set type is static, and then I can commit the changes. Palo Alto do recommend that most of the configuration you can do using GUI. So rest of configuration for the internet access, I would do using GUI. For that, I would access my lab, I mean this firewall device, using this workstation. So I have clicked on the workstation. I'm able to open it. Now I can assign IP to this workstation. So let me just go and open ncpa.cpl so that we can assign the IP to this workstation. So I'm just going to assign internal IP, which is 10.0.0.10, and subnet mask is /24, which is 255.255.0. Apart from this, I'm just going to assign another interface IP, which is this one. And for this interface, I'm going to assign IP 192.168.2.10, and subnet mask is 24. And the gateway would be my firewall IP, which is 192.168.2.1. It's not defined yet, but I would define later, and I would assign IP over here 8.8.8.8. Sorry, DNS over here 8.8.8.8. Right. So now I have assigned the IP, and if I try to ping my firewall management IP from here, I can ping, right? CMD ping management IP, which is 10.0.0.1. It must be reachable. Yes, it's a reachable. So I can access this firewall using GUI. So I would access the Chrome, and from Chrome, I would try to type here my firewall management IP 10.0.0.1. I should be able to access it. Yes, I'm able to access it. Let's proceed and save. Put the username and password. Username was admin, password was test @123. Let's log in. and now I can access my firewall. So right now I'm managing this firewall individually. I don't have any panorama right now. So this is single firewall. I'm trying to access it and I'm trying to manage it. So this is the dashboard of the firewall. There are different tabs: dashboard, ACC, monitor, policy, object network, and device. So dashboard is giving you basic information where you can see device information. What is the device name, management IP, model, what is serial number, what is the software version. So we are running 9.0.4 over here. That's a pan OS version. This is operating system version. If we just want to configure interfaces, so we can go to network interfaces, and as per our plan, we are going to assign IP address to Ethernet 1/1 and IP address to Ethernet 1/4. Here we can go Ethernet 1/1, and only you can configure IP address if your interface is on layer 3 mode. So we can configure interface as a layer 3, because as you know that layer 3 is for routing, which is network layer. So that's why we have defined layer 3 over here, and here we can select what is the virtual router. So by default this is using default one. So virtual router is nothing but this is for the route segregation. So this is the virtual router default one, and here we can define what would be the security zone for this interface. So this is a zone based firewall, so we can define security zone. I'm defining this security zone to this firewall as a trust, this interface as a trust. So this interface would belongs to trust zone, and now I need to assign the IP address. So let's assign IP address. I'm putting IP address like 192.168.2.1, that is /24. So that's IP address I have defined over here, and now I can click on OK. And then 1/4, I am just going to define 1/4 as a untrust, but it required an IP, so I would define as a layer 3. This would be part of my virtual router, and zone I'm just going to create over here. I can give untrust to this. Untrust means internet. This is public network. And now I can assign the IP address. So it would be taking IP address from DSCP client. Okay, this would be working as a DSCP client, so it would take IP address from DSCP. After assigning all these things, we can commit so that it can take the IP address from DSCP. Okay, so task is still running. I can click on task and I can see the commit is still running. And the changes which you made, only that changes be effective after commit. Okay, so it's completed now, and now I can click on close, and I can see that what is the IP address assigned. This is 1/1.22 is assigned, so I can define NAT for this IP 1/22. So let's define NAT. So I would go to policy, and I would create two policy. One policy which would be allowing the traffic from internal to internet, and the other policy for netting. Okay, so let's create that. So first create security policy, that is allowing the traffic. Okay, so allow _ internet access. So I'm going to define if source is my trust zone and source network is 192.168.2.0/24. Okay, if the source network is this, destination network is any. Okay, so destination zone would be untrust, and destination network I'm selecting any over here. Application, it could be any application, but by default I'm allowing these three applications. One is the web browsing, web browsing. Web browsing application. Other is SSL application for the HTTPS traffic. For Google, if I just want to access Google, so for Google we have to allow Google based services, this one. And now I would go to service category, I can define over here. Do we have any application for DNS? Let's see if I have any application for DNS. Yes, I'm just going to allow DNS as well because my DNS is configure 8.8.8 from internal. So DNS should be allowed. And we don't want to allow any port. I just want to allow application. If you want to allow ICMP as the ping, you can define ping application. Sorry, PING. You can define ping application as well. So all these applications are allowed from inside to outside. And now I can define net policy. So on net policy, we can add net. And this time the net which I just want to create, I would define what kind of net I just want to create. I would say net underscore rule. Origin of packet, I can define that packet should be coming from trust. Destination zone would be untrust. Destination interface would be in 1/4. Source would be my internal network, which is 192.168.2.0/24. And destination could be any. Translation, how translation should be happen. So translation should be happen based on the source IP and port. Okay, sorry, dynamic IP and port. We are taking PAT over here. And only source we are going to translate. And this is going to translate the source on this IP address 192.168.1.22. This is the IP address of outgoing interface. And only source is going to translate, not the destination. Rest of things would remain same. And now I can commit it. Post the commit, I should be able to access internet. Let's see. After that, I would try to access internet from here. So I'm trying to access a website, which is google.com. And I'm able to access. Okay. And if I check the connection on over here on my firewall, if I go to monitor option and check the connection using session browser, I should be able to see all those connections. Okay. Google base, Google Play services. These are the connection already open. So this is the Palo Alto. The basic we talk about the Palo Alto. Okay. For advanced things we do cover in our course, everything in our course, and hopefully you have seen our course content, what we are going to cover over here. So if you haven't seen, so I would recommend you go and visit netminion.net. This is our website. And here you can choose the course. And for Palo Alto, you can go for Palo Alto. And you can see here. So we have multiple video as well, training video uploaded over here, right? And you can see the course as well. What are the course we are going to cover here? So here you can download syllabus and we can open it. This is the course content where we are going to cover initial configuration. After that, interface configuration, security and net policy, app ID, content ID. In content ID, we are going to cover antivirus, etc. We are going to cover file blocking policy, decryption, user ID, right? Management reporting, active and passive high availability, and active as well. So all these things we are going to cover in our course. Okay, so that's all for demo I had.
That's fine.
Yeah, if there is any question, Ismail, you can ask me right now.
I know nothing at the moment. I will check all the like training details which you have shown on the website.
Okay. Okay.
What syllabus you are covering, then I will let you know.
Sure. All right. Thank you so much for joining the demo. Hopefully we are going to see you in next class.